Hi everyone, today we're going to be learning about tree diagrams. And now tree diagrams can be used for any events that, any outcomes that involve two or more steps. Right, so we've looked at events that have had, two combined events, or we've just looked at single events. But what we're looking at is something that actually has multiple steps, okay? So let's look at this example of just a fair coin, right? And we're flipping it twice. So a fair coin, we're assuming that we have that outcome of heads or tails. Okay, we're assuming those outcomes are half and half. And so I'm going to start off just with my two branches here. And I'm going to call heads H and tails T, right? And then just on the branches there, we're going to write down the probability of those events occurring. Okay, so that there was step 1. Now we're going to write down step number 2, okay? And we're once again flipping that coin. So it's either going to be heads or tails, and once again, they're going to be 1/2 each. And so that is step number 2, okay? And now the trick with tree diagrams is that to find the probability of something happening, we can multiply just along the branches, right? So let's say I wanted the probability of getting a heads and then a heads. I'm going to follow this branch here, okay? And so to get that, I'm going to do 1/2 times 1/2, which is equal to 1/4. And so those of you who have played that heads or tails coin game know that to get 2 heads is a 1 in 4 chance. Now let's say that instead we wanted to look at the probability of getting a heads and a tails, right? In any order. We're going to follow 2 sets of branches here. We're going to follow the heads to the tails, and then we're going to follow the tails to the heads, okay? And so that's going to be 1/2 times 1/2, and then adding on another 1/2 times 1/2, okay? So that would be 1/4 plus 1/4, which is 1/2. And once again, if you've played that heads-tails game before, you know that that's a half chance, right? And so we can multiply along those branches and then add outcomes together if we need to. So now that we've talked about that, if you would like to, feel free to pause here and give this a go. Now we're starting with something that has 4 outcomes here because we're picking a letter from a word. And then we've got a coin being flipped. So my first set of branches is going to have the letters T, R, A, and P. And each of those branches is a 1 in 4 chance. Then from there, for our step 2, we're flipping a fair coin. So that is heads or tails once again, and we're assuming that because it's a fair coin, it's going to be a 1/2 chance along all of those branches, right? And so how many outcomes have we got possible here? Because we've branched off twice from each original outcome, it's going to be 4 times 2, which is 8, and we can count those down the side. Then if we wanted the probability of the letter T and then heads, we're going to follow those branches along, okay? So that's going to be 1/4 times 1/2, which is equal to 1/8. Now, if we want to find out the probability of consonant and then tails, remembering consonants are not vowels, we're going to follow the T onto the tails. And we know that there is 1/2 times 1/4, so 1/8. We're going to follow the R to the tails, and that's also going to give us 1/8. And then we're going to follow the P to the tails as well. And that's once again 1/2 times 1/4, giving me 1/8. And so if I want all of those together, I am just going to add them, giving me 3/8. Now this one here is a bit trickier because our probabilities along the branches actually change. So it's really important you read the question carefully. Now I've got new captains that are being chosen for a mixed netball team. We vote for the captains first and then we vote for the vice captains, okay? Now, I've got 6 girls and 11 boys, so I'm going to start with, 5 boys. So I'm going to start with 11 people to choose from. But on this branch here, I'm just going to have a boy and then a girl, right? And that's going to be my captain branch because my captain is picked first. Now, the assumption we're making here is that if you are captain, you cannot also be vice captain, right? So assuming these students all have an equal chance, then to have a boy captain is a 5 in 11 chance and a girl captain is a 6 in 11 chance. Then we're going to follow for our vice captain branch. Okay? And now what's going to happen here, because you've actually taken an option out because you voted for your captain, this is called an experiment without replacement. Okay? And that's because we're taking an option away and it's staying away. And so now instead of being out of 11, these are actually going to be out of 10, right? And so for that first branch, if we're saying a boy has been voted, we're left with 4 boys and then 6 girls. Whereas on that second branch, we're left with 5 boys and then we're left with 5 girls, right? And we can simplify these down as well to make both of these 1/2. And it's just going to make our calculations easier later on. And then this would be 2/5 and 3/5. Okay. So what's the probability of a boy captain being chosen? We're just looking at that first branch, okay, because we're just looking at the captain side of things. And so for the boy captain, that's going to be a 5 in 11 chance. Now, the probability of a girl captain and vice captain being chosen, we're going to follow the 2 girl branches on this side. And we're going to multiply those together. So it's going to be 6 over 11 times 1 over 2. Okay, 2 and 6 would cross cancel, giving me 3 over 11 being the probability there. So if you can understand that tree diagram, you are set for all tree diagrams we can throw at you.